The cornerstone of the European Space Agency's contribution to the International Space Station, the laboratory module known as Columbus.
Columbus is one of the most important European contributions to the International Space Station. In the same way as other ISS elements, Columbus will be taken out of the shuttle's cargo bay with a robotic arm. It will then be attached to another European-built element, the Node 2.
As you can see, this is a laboratory. It's a pressurized laboratory. It's about 5 meters long, 4 meter diameter, and it accommodates what you can see here, scientific experiments. Here you have 4 racks, and it can accommodate up to 16 racks of scientific experiments. And it allows 3 crew members to operate this module and to generate science in a short-sleeve environment. In addition to that, there is an external platform outside that can accommodate up to 4 facilities. We are going to launch 2 of them, Solar and UTEF, and they accommodate outside on the so-called EPF.
Each rack is a laboratory in its own right for research in different disciplines in space. The European Drawer Rack is designed for scientific experiments in a variety of subjects in all of its 7 interchangeable drawers. The European Physiology modules are dedicated to experiments to better understand the workings of the human body. Biolab is designed for biological research in space, investigating the role that microgravity plays on all functions of an organism. Together with the EPM, experiments in medical and pharmaceutical research will be performed, aimed at the application of improving health on Earth. The Fluid Science Laboratory allows research into the dynamics of fluids. The first experiment to be performed might help to better understand the flow of the fluids in the outer core of Earth. External experiment facilities can be mounted outside Columbus. 2 of these will be launched together with Columbus this year. The first, called UTEF, includes several technology demonstration experiments, including exposure to space of new materials. The other, Solar, measures the radiation from the Sun to understand its influence on Earth's atmosphere and its climate. The internal facilities are already installed in Columbus, so that the experiments can start immediately after it has arrived at the ISS. On board, the ISS ESA astronaut Leopold Earts will support the activation and checkout of Columbus and its experiment facilities.
Well, the scope of this Columbus mission this is the first mission for Columbus, so we are going to bring it up in the shuttle and then unload it from the payload bay of the shuttle and attach it to the station. And then we make all the connections and activate the module. And then there will be, during the rest of the flight, which is a long-duration flight for me, a lot of commissioning tasks. Means making sure that all the systems, all the scientific facilities are working correctly.
While Leopold Earts and his crewmates will conduct experiments in Columbus, the researchers on ground can take part in their investigations as if they too were on board, thanks to advanced communication technology and imaging systems. The experiments carried out in Columbus will be scheduled and supervised from the Columbus Control Center at Oberpfaffenhofen in Germany. Through this control center, researchers all over Europe can receive the results of their experiments in real time. Former ESA astronaut Reinhold Ewald is one of the ESA mission directors for the Columbus operations.
The Columbus Control Center will come into action soon. We are simulating right now the mission of the Columbus Laboratory. The Columbus Laboratory will be attached to the International Space Station, and then the Columbus Control Center will join the sequence of control centers all over the world. Houston, Moscow, and Munich will be called in order to control the systems of the Columbus Laboratory.
Although Columbus is smaller in length than the other modules of the ISS, thanks to the ingenuity of the European engineers that have designed Columbus, It offers the same number of racks for research as the American and Japanese laboratories. And, by being smaller, all the initial internal and external payloads are launched together with the module, thereby saving extra launches, time and expense. Once in place, Columbus will begin to bear the fruits of Europe's investment in the ISS program. Its scientific results will give us a greater understanding of life on Earth and further the development of technology. And it will undoubtedly make every European feel proud that their space agency, ESA, is a part of the biggest international research project ever undertaken.